In this video, I want to introduce you to a concept that is regularly used in capital budgeting called net present value. The first learning objective that I have for you on this is to basically understand kind of how net present value works. And so reason we start with net present value is it is considered the gold standard with respect to making capital budgeting decisions. By that, what we mean is properly applied, it always leads to the correct decision. When in doubt about what to do, using any other sort of rules that you use inside of your company, you could always go back and apply the NPV rule, and it will give you the correct answer from a valuation standpoint. So what I want to do is to have you basically be able to explain the NPV rule using examples of your own design. So I want you to be able to describe how it's calculated and how it's used to determine whether or not to invest in a project. So you'll find with all of these there is a metric that you calculate, and then there is a decision rule that you apply for how to use that metric to decide whether to do a project or not. And I want you to be able to explain that and describe it. I want you to explain the logic for why it leads to the correct decision in terms of a go or no go on a project. So should we do it or should we not? And I want you to be able to discuss some of the issues that arise in using the rule to make decisions in the real world. And so some of the things that people will bring up if you suggest, oh, let's just do an NPV calculation, as issues that they have with net present value. So first thing, remember that the responsibility of management when it comes to making capital budgeting decisions is to select projects that add value to the value of owner's equity. And so they're adding value for shareholders. Remember that shareholders are ultimately the owners of the company. They are the management's boss. And so you want to be making the decisions that will add value for your boss. And so when faced with a choice between multiple projects that all add value, it's the responsibility of the management to select that subset of the projects that add the most value. So we're going to look at it in terms of kind of two scenarios. One is I've just got a bunch of projects, I've got plenty of money, and so and no other restrictions. I can just pick from any combination of them that I want. Under that situation, you pick any of them that add value and you don't pick ones that don't. In the alternative situation where maybe you have a whole bunch of projects that all add value, but it's simply not possible for one reason or another to pick all of them, then what you want to do is think about the combination, given your constraints, that creates the most value and therefore maximizes the value to your shareholders among the choices that are presented to you. So that's kind of the thing that the shareholders expect of you as management, and that's the guiding principle for all capital budgeting decisions, not just using the NPV rule, but for any of them. So let's talk about the net present value metric itself. It is defined simply as the present value of all of the future cash flows. So in this case, you've got future cash flows happening in year 1, 2, 3, 4, 5, minus the initial investment amount that you're going to make today, let's just say, or whenever this happens. And so you want to discount the future cash flows back to the same date as the initial investment. All right. I don't want to say discount them back to the present, because sometimes you will be looking at a project that you may not even make the initial investment for a year from now. And to use the NPV rule, what you would do is you would basically say, okay, the day that I make the initial investment, that's day 0 of the project. That's when it starts, basically. And so I would be discounting cash flows back to the day of the initial investment. not back to today. I wouldn't add that extra year of discounting back. All right? And so what it would say, what NPV would say is, let's calculate these amounts, right? Let's determine these amounts. So I've got the example, 200, 300, 400, 500, 600. And then let's discount them back to the present value, right? And then let's take the difference between the initial investment and the present value of those future cash flows. So I want to show you some example in Excel of this, because I want to make what I think is a relevant point here, particularly since we've just come out of a unit on present value in general. All right. So let's just click over here real quick and think about what they're saying. So imagine I have an initial investment of $1,000. I've determined that the investor required return is 10%, so my cost of capital is 10%. And again, in period 1, I'm going to get 200, period 2, 300, period 3, 400, period 4, 500, and period 5, 600. And so I've just calculated the discount factor at 10% for each of these. So the discount factor, remember, is you're going to take your 1 plus your interest rate, raise it to the number of periods you need to go back to get to present value. And you're going to take that whole amount and you're going to go 1 over that amount. And so think of this factor as saying basically $1 that I receive a year into the future from the initial investment is only worth 91 cents on the date of the investment. A dollar received 2 years from the initial investment is only worth 83 cents on the date of the initial investment, and so on. So that's kind of the way the discount factor works. Then I just calculate the cash flow times the discount factor, gives me my discounted cash flows, and I sum all of those up, right? And so you can see the formula, it's just 1 times the other there, but then I sum all of those up, and that sum becomes the present value of the future cash flows. So that's 14,444.34. And then on NPV, I subtract from that the $1,000 of the initial investment, and I have an NPV of $444.34. So it has a net present value of $444.34. It's positive NPV. We like that. Now, I just want to make this point to you. If we were to just do a regular present value on this project, instead of having that investment setting out separately, we would say, oh, in period 0, we have a negative cash flow of 1,000. We have positive cash flows, just like in the other project, out to year 5. The discount factor at time 0 is 100%, basically saying $1 that you receive on the date of the initial investment is worth $1 on the date of the initial investment. And again, $1 received a year after that is worth 91 cents on the date of the initial investment. So you go and you calculate again all the discounted cash flows and you sum them all up. It's 444.34, the same number you get for NPV. Point here is I don't quite frankly know why the industry is so wrapped up with, and the theory, not really the industry, is so wrapped up with this net present value concept, when in fact it's just present value. Take the N off. It really is, you just solve for the present value of all the cash flows from your project, and that becomes the metric. So I wanted to show you that so that you guys wouldn't be thinking, wow, there's this huge difference and I'm not getting it between present value and net present value. Don't trouble yourself. This is all there is to it. All right. So once we've gotten those values, now we have to apply our rule. The rule for net present value is pretty straightforward. The amount of value that your project adds above and beyond the cost of capital is equal to this net present value calculation that you did. So in our example, the $444 is how much money, additional money or value in present value terms the project adds above and beyond the 10% per year cost of capital. And so if the amount added, which is the NPV, is greater than 0, then the project adds value. So thumbs up, you're going to do it. If the NPV is equal to 0, the project's a break even. It means that it's just makes enough money to pay the cost of capital and doesn't add any value. We don't waste time with that. So it is also unacceptable, or it is unacceptable, sorry. And obviously, if the NPV is less than 0, then you're actually going to spend money to do a project that won't make enough money to even pay back the cost of capital. And so it's actually destroying value for your company and definitely is unacceptable. Okay, so let's kind of walk through, hopefully this will help you. Let's walk through the logic for net present value. When you're considering using that rule, consider that there's a choice for any one project between either doing that project, which would be investing the money in the project, or not doing it and just giving the money back to the shareholders and letting them do what they want with it. So if we invest the money in the project and it has multiple cash flows, let's just assume that at the end of each year, we're going to give those cash flows as dividends from the project back to the investors. So they're not going to get the original $1,000 that we had in there. Instead, they're going to wait and they're going to get the cash flows at the end of year 1, 2, 3, 4, and 5. And they're going to take those cash flows as they get them, and they're going to reinvest them in the other projects, or in some other project that earns 10%. All right, some other investment that earns 10%. And they're going to hold them in that investment until the end of this project. And so what we're doing is basically saying there will be some future value of all of the cash flows to them that we give them, plus the amount that they earn from investing those. Option B is that we could just give the $1,000 to the shareholders and let them invest that at 10% for 5 years and get the money out of that. And so ideally what you would say is whichever of those options leaves the shareholder at the end of 5 years with the most money should be the one that they want, and therefore that's the one we should do with them. So let's consider the first option. We'll do the project. So look at the cash flows to the investors. We're not going to give them any money at time 0. So they get no money at time 0. I calculated a compounding factor over here, which is again just the 1 plus 10% raised to the power of how many years they're going to be able to invest this. So since we're talking about a 5-year project, they'd be getting it in time 0. They'd have a whole year to invest it. So it would grow to be 161% of what you started out with due to this 10% investment rate. But they're not getting any money, and so that's why there's future value at the end of year 5 for their cash flow is 0 on that one. Instead, they're getting this money. So they're going to get $200 at the end of year 1 that they can invest for 4 years. It's going to grow by 146%. It'll be worth $292.83. $300 at the end of year 2 that they're going to be able to invest from the end of year 2 to the end of year 5. So for 3 years, grows by 133%, goes to $399.30. You can just keep doing that, and obviously at the end of year 5, they're going to get their $600. Since they're getting it at the end of year 5, when we're evaluating values at the end of year 5, there's no years for them to invest it, so it's just worth the 100% of $600, so $600. If we summed all that up and said, so what's the future value at the end of year 5 that the investor would wind up with from doing the project, the answer is they would wind up with $232,326.12. So that's what the value to the shareholders are if we, instead of paying them out a dividend of $1,000 today, we invest that $1,000 and pay them out the dividends in the forms of cash flows each period going forward. They'd wind up with $23,26.12. Now, if instead we just go ahead and give them the $1,000 today, then we're going to give them that today. Again, they're going to invest it for 5 years. It's going to grow at 161% of its value. So it'll be $1,610.51. All right. They won't get any cash flows in the future years because we didn't invest it, so we don't have those cash flows to give them. And so they're just going to wind up with the 1,600. So again, if we do the project, 2,300. If we don't do the project, 1,600. Okay. Now, so the difference between those two values is basically the difference between doing the project or not. And so we think we're adding value by doing the project. And in fact, that's the way that the rule works. So if it's such a good rule, why is it that not everybody uses it? And in fact, not everybody does use it. So, let's think about that. Well, the first thing is, in order to apply the rule, you have to have those projections of future cash flows. And we know from our own experience, it's sometimes challenging to predict the future. I mean, we really can't, and so we're doing our best guess. And then it's sometimes more difficult to then get a group of people to all agree on what the reasonable timing and amounts of the cash flows can be. And so we went through this earlier. You saw that not everybody agreed on what you came up with as cash flows for your projects. Secondly, it is not based on accounting earnings. It's based on the operating cash flows that we've defined in earlier discussions. So it's expected values, incremental, after tax, and it is operating cash flows, actual cash, assuming no debt financing, so no interest charges in there. And so it's a little bit more difficult than just going and grabbing a number from some pro forma financial statement that you have. And so some people find that off-putting. It does assume that we know for sure what the initial investment will be. Well, remember what we said before. You're evaluating the projects today, but you may not even make the initial investment till a year from now. And so between now and then, the amount of the initial investment could change. Even if you were doing the project today, you probably just have an estimate of what the initial investment is. And quite frankly, that estimate could be wrong. You may have missed a cost. You may have overestimated a cost and it actually comes in under. So there's all this estimation that's going on. It is sometimes viewed as difficult to determine an appropriate discount rate. We went through a little exercise in class. You guys could see how that might happen. But it is difficult and time consuming sometimes, and people are put off by that. And then you'll find, we'll talk about this in just a minute, that it's sometimes confusing to apply the rule in situations where we can't do all the positive net present value projects, either because we just don't have enough funding or maybe they're mutually exclusive. And so some people are put off by the fact that you have to sort of think a little bit outside the box to apply this in these other situations. So again, just to kind of be balanced in this discussion, yes, it's the gold standard. Yes, it will, properly applied, it will always give you the correct answer in terms of what the right projects to do or not do are. But to be fair, it does have some detractors who don't necessarily like it, and they don't like it for particular reasons. And, so we want to make sure that you're aware of those. Second objective that I have for you with respect to the net present value would be to go through a couple of those situations where it's kind of hard or you have to think a little bit more to apply the net present value rule and have you be able to basically go through and properly apply the rule. And so I want you to be able to set up an example of your own design and then talk about in each of these scenarios, capital rationing or mutual exclusivity, how you would apply the rule and why that makes sense. All right. So capital rationing in a nutshell means that we have insufficient funds to do all the positive NPV projects. So easy way to think about it is lots of people in your company come up with lots of different project ideas. Turns out that many of them are very good ideas, but let's say that the the total amount of money that it's going to take to do all of those projects is like, $20 million. And you can't come up with $20 million from investors. You can only raise $10 million. So that would be, we've got a whole bunch of positive NPV projects. We now have to decide which positive NPV projects to do and which ones not to do. Mutual exclusivities, a little bit different. That would be, let's say that if I were to do a project, I can't do another one. And so sometimes these are just two different versions of the same project. Some examples that are often used are maybe one of them's you've got a large version and a small version, and the large version you got to spend a lot more money, but you get some more money. In the small version, you spend less, but you get less. Sometimes it's not that. Sometimes it's a competing resource. Maybe I've got a particular plot of land, and I've got two choices for things that I could do with that land. But if I do one of them, I can't do the other one, right? You can only use the land for one of them, not both. Or maybe a piece of equipment that we use. Sometimes it's about where maybe want to sell product to a particular customer to meet a particular need, and we've got two different choices of how we could go at what of the types of products that we could develop and sell to them to meet that need. And we've determined that we're either going to sell them one or the other. We're not going to sell them both. So lots of times where this mutual exclusivity comes up. So let's talk about the capital rationing. Again, here you have more than enough NPV projects, and you have to decide among them which of them should you do based on the amount that you can afford to do. And so let's just kind of see how you might apply that. Let's just say that you were only, again, as we talked about before, able to raise $10 million. You've got 3 projects. You can do all 3 of them. They're not mutually exclusive. There's nothing that prevents you from doing all 3 of them in terms of that. But the total cost of them, you got Project A at $8 million, Project B at $6 million, Project C at $4 million. Total cost to do all of them is $18 million. You don't have $18 million. And so you got to decide what to do. Well, it doesn't take a rocket scientist to figure out in this particular situation, if you start making combinations, there are only a certain number of combinations that fit inside the $10 million threshold. We could just do one of them. We could do either A or B or C. Or we could do A, and if we do A, there'd be not enough money to do B or C. Or we could do B, and then we couldn't do A, but we could do C. Okay? And those are really the only combinations. And so what you can do is look at those different combinations. If I do A, I raise $2 million. Okay? That's the NPV. If I do B, 1.5, C, 1 million. Well, obviously, since these are all positive NPV, doing B plus C is better than just doing B or just doing C. So I add those up, and that's a total of 2.5 million. So I can either do A and raise 2 million and create 2 million in value, or I can do B and C and create 2.5 million in value. And so what NPV says is, well, the combination that has the highest NPV is B plus C, so let's do B and C. And that would be how you would solve that. There are some who would react to that and basically say, well, that's not putting this on a fair basis because you have to spend $10 million to make that $2.5 million, whereas you could make $2 million by only spending $8 million. And to that, I guess what we would say is that again, your responsibility to the investor, the shareholder, is to give them the most value, not the most return on an investment, if you will. And so if you can raise $10 million and put all of that to work, you should do that. If that's going to generate more dollars, actual dollars, than if you were to only raise 8 million, even though you could have gotten 10, and put just the 8 million to work. And I think that if you went through the same sort of example as we did before, saying, okay, well, so one option is that we raise the $8 million versus, or we give the investor 8 million and see what's left at the end of 5 years, let's just say, or we raise 10 million and do projects B and C versus just giving the 10 million to the investors, you could immediately see that giving the investors a $10 million dividend is superior to giving them an $8 million dividend in all cases. And so we would always, if we had a project that we could put to use $10 million and it generated more value than raising $8 million, we would always do that. So the next thing we want to consider is a situation where you have the option of doing one of two projects, or maybe three. I think in our example we use three. You can do either, but you can't do both. How do you decide? So the example I have here is consider these three projects and really think of this as sort of a scale issue. We could either do a small version of a project and make 20 million off of it, or we could do a more expensive sort of medium version and make 25 million, or we could do a larger version, 30 million, and make 28 million. And in this case, we're assuming that we could go raise the 30 million if we want to. We're not limited in terms of capital rationing, but now we just have to decide what to do. Well, again, what the NPV rule says is whichever one of them has the highest NPV, that's the one you do from a mutual exclusive situation, right? Assuming that you can raise that much money, that's what you do. And so it would say pick project C. And again, you might come back and basically say, well, wait a minute, I get 100% return on my $10 million here. I get, 100 and, well, I guess a 200% return here. I get, 125% here. And here, I don't even get 100% return. How can that possibly be the best choice? And the answer to that, once again, is start with the idea of the alternative. If I can raise $30 million, then I could take that $30 million, give it to investors, and let them invest it. And they would always prefer that to me giving them $20 million or $10 million and letting them invest that at the cost of capital. All right? And so the threshold here is just that it's got to be, it's the amount of money versus the cost of capital. That's what the project is costing. That's what's being taken away from the cash flows to get to this NPV. And so that's the alternative you're comparing against. And so just using that logic, you could sort of eliminate and say, I probably won't take the smallest one or the medium one, just solely on the basis of how many dollars are involved. I would take the biggest one, if in fact they're all positive and it is also the highest NPV. So that's kind of that logic. And again, I think you'll find people that will argue with you and basically say, well, no, why don't we just do project 2, A and B, right? That's 30 million, and that gets us 45 million in results. Key here is this is a set of mutually exclusive projects, meaning if I do A, I can't do B or C. If I do B, I can't do A or C. So that's the deal. Now, the caveat to this is if we were going to spend the 30 million on project C, and that prevents you from doing some other project. So let's just say that if we did project B at 20 million and it raises 25 million in NPV, and that freed us up $10 million to do some other project that's not mutually exclusive, and that project added more than $3 million in value, then clearly project B plus whatever that $10 million project would be better than doing C. All right? And so it's not, you sort of have to go back to the what are all the positive NPV projects, what are all the possible viable combinations of those that on the one hand don't put two projects, put together a combination that has two projects that are mutually exclusive in it, and then the other hand doesn't have a total investment amount that's more than we can fund. And so you're really just, again, creating sort of all those possible combinations and then picking the one that has the highest total NPV. So it's sort of a simple rule, it's a little bit complex to apply, figuring out those combinations. But at the end of the day, it always gives the right result. All right. So that's net present value. That's what all the hullabaloo is about in capital budgeting is, everybody wants you to know net present value, know how to apply it, and that's why. And these are some of the issues that arise. Hopefully you'll find that useful. Thank you.